Hello and welcome. Today we'll be taking a look at Chapter 5 of the Open Learning Initiative Logic Improves course in logic. So Chapter 5 is going to deal quite a lot with negations and falsums. Falsums are what happens when you run into a contradiction. So these are very useful ways of setting up logic problems, mostly because, frankly, sometimes you can't get at what you want. Well, if you can find out that the opposite of it is not what you want, then ta-da, there you have it, right? Sort of a little binary trick. So let's take a look here. We'll just run through some problems. Here we see the idea of a Falsum introduction. If we have a some sort of an x, and then we also have its negation, we end up with a falsum. Negation introduction is what we get when this is working backwards. We have a line where we have a negated idea in our conclusion. We assume that we can get by with a non-negated feature, so we take off one of the negations, and then we see if that results in a falsum. If it does, then the non-negated idea can't be true, and that justifies why it is that there is a negation in front of that element. So let's jump straight down into some of the Logic Lab stuff. As a general rule, we always want to be able to sort of work our way through the problem intellectually before we actually start hitting buttons, because we don't want to be button monkeys. We want to actually be able to solve problems. So before I even get started in on this guy here, for example, what I can notice, is this gonna work? No, I gotta do this manually. So I have this not P, which is supposed to be my conclusion. So I want to try with a negation introduction, so I'm going to draw a magical box. I call it a magical box because you have to make an assumption which isn't warranted to begin with. And that assumption is going to be P. Alright, so if I have P, what can I get? Well, if I have P, then I can do conditional elimination on line 1. That will give me Q or R. And then I can see that my line 2 is the opposite of that. It's not Q or R. And there is the sort of problem. So, that's how we are going to solve this thing. Whoops, I guess I hadn't gone back in here for a while. So we're going to do a negation introduction on line 3. Here we go. Conditional elimination, lines 3 and 1. That is going to give us our Q or R. And then we do a Falsum introduction, lines 4 and lines 2. And there we go. That's a problem. Or rather, that's the entire problem. Now, if we take a look down here, again, we can intellectually sort of solve this. What you want to do is take a look at what we have as our conclusion, which is not E or C. So we're going to do negation introduction, which will give us E and C. It's supposed to be a plus sign. Sorry, I'm actually drawing here with my mouse. It's terrible. So once I have that, I can pull out E, and I know that I want E because just looking at my premise on line 1 here, I see that the E is negated there. So from here I can pull out E, and then I can do a conjunction elimination to the right and pull out the not E, and there's my problem. So let's take a look at this real quick. Reset the whole thing. We'll do negation introduction, apply, we get this. Elimination on the left to get E out. then elimination on the right, inside the box, Falsum Introduction, E and not E, and we're done. Finally, we can take a look here at problem number 3. Problem number 3, we have not P as our conclusion, so we're going to assume P or negation introduction. If I have P, then I can get Q with conditional elimination. And then if I have P, I can also get not Q. That's another conditional elimination. And there's my falsum, and then we're done with that. So let's make sure that's how that works. In fact, oops, my bad. I should probably be doing this on a full screen and zoomed in. So we're going to do negation introduction. There's our assumption of P. Conditional elimination, lines 3 and 1 will give us Q. Conditional elimination, lines 3 and 2 will give us not Q. Falsum introduction, lines 4 and 5 give us a falsum, and then we're done. So that's our negation introduction. Let's take a look at some of the other things we have going on here. This is negation elimination. So it works the same way as negation introduction. You start off with your conclusion, except this time instead of getting rid of a negation symbol, we're going to add a negation symbol and see if we can run the whole thing into the ground by producing a falsum, right? An internal contradiction. So again, here we should be able to solve these intellectually first before we ever start clicking any buttons. So here we have I as our conclusion. So if we do a negation elimination, we're going to assume not I. If I have not I, then I can get B, right, as a conditional elimination on line 1. And then if I have B, I can get I through conditional elimination on line 2. And then I have not I and I. There's my falsum. That'll be that. Let's take a look down here. T. This one looks a little funny because you go like, well, how exactly am I supposed to solve this? Well, you're going to assume not T. Right, so that's a negation elimination. And then I can pull out S from line 3, let's say. If I have S, then I have not P. Right, that's a conditional elimination on line 2. Then I can also pull out R from line 3. And if I have R, then conditional elimination on line 1 will give me P. So I have P and not P. There's my contradiction, and we're done. Finally, let's take a look down here. For problem 3, we're going to do negation elimination again. This time we're going to assume a not L. Right. Then I'm going to use lines 2 and 1 to do conditional elimination, which will give me L or B. And then I'm going to do a disjunction elimination of L and B, with my goal being the falsum created by the not L box. So I'm going to end up with a box that says start with L and in a falsum. I have L and not L, so that one checks out. My other box is going to start with B, and I have to produce a falsum. Well, that's easy enough because line 3 gives me not B, and there's my falsum there, and then I'm done. Alright, so let's take a look at whether or not we can solve these exactly in the way we talked about. Give this thing a second to actually load. So again, understandably, some of these are a little rough, right, if you're not used to them. But it's worth sort of checking out what you have. I mean, all you're doing is you're giving yourself an option of creating a couple of new features, and then what you should be doing is taking those features and using the kinds of skills that you learned in chapter 4 to see what you can mess with. So we have conditional elimination lines 1 and 3. That gives us B. Conditional elimination lines 4 and 2. That gives us not I. Falsum introduction lines 3 and 5. Give us the falsum, and then we're done. Say close to problem 2 here. You zoom into that a bit. Right, so we are going to assume is negation elimination on T. Notice, by the way, that the T doesn't do anything other than saying that, like, look, we assumed not T, and then we ended up with a contradiction, so it must be T. Although, if we're going to be perfectly honest, if we assumed T, we would have ended up in the exact same place. So we're going to do elimination on the left, inside the box. Apply that, we get an R. Conditional elimination 1 and 5 gives us P. Conjunction elimination on the right, inside the box, gives us an S. Conditional elimination lines 2 and 7 are going to give us not P. Falsum introduction lines 6 and 8 give us a falsum, and then we're done. Let's take a look at the third option here, third problem. Whoops, too far in. So we're going to do negation elimination on the L. Now, you might be wondering, why are we even doing this? Well, it's because with these premises, I somehow have to arrive at the idea of L. Now, granted, looking at these premises, it's kind of straightforward. If I have a true antecedent for number 1, which is found in line 2, then my consequent here, which is L or B, has to be true. And the only way for L or B to be true is for either L or B or both of them to be true. And then I find out in my premise number 3 that B is not the thing that's true. So what we're doing here is we're saying, like, look, let's take a look at what happens if L weren't true, and if we can find a problem there, then ta-da, L has to be the part that's true up top. Alright, so we're going to do conditional elimination lines 2 and 1. Inside of this box we have L or B. We are going to do a disjunction elimination with the goal of the falsum. Here's my first falsum, which is L and not L, so we're done with that. Here's my second falsum, it's this B and not B. And so we know that L has to be true. Alright, so that's all 3 of these problems. Jump back in here. Go to the next page. Finding contradictions. So they have this procedure for attempting to not destroy your life. Attempting to somehow force a contradiction where one doesn't necessarily exist. They have quite a lot of very fun problems here for you to dig through. What we want to do is jump over to the next page. Alright, so we're going to open up these problems, because these are actually quite a bit tricky. I think, yep, I gotta reset them. Alright, so when you're looking at something like this, it's actually highly helpful sometimes to take the very reasonable step of taking your conclusion, even if it is a conjunction, and applying it backwards. So what that gives you is both of the conjuncts will show up as separate goals, right? And then what you can do, now I'm looking at this, I have D and I have A, that's wonderful, but I can't pull a contradiction out of that. But if I look at my premise 1 and premise 2, I'll notice that both of those are contradictions in and of themselves, right? So, by the way, how do I know that these are contradictions? Because they're the same atomic statement that is reversed. So, if I make D here false, then my consequent is going to be false. My antecedent which would have been false, now with the negation becomes true. And so I have a statement that says if true then false. That doesn't work in conditionals, so I know that there's a problem. So what I'm going to do is I'm going to do a negation elimination on D. That will let me assume not D. Once I have that, conditional elimination for the not D, so lines 1 and 4, that produces D. And now I have Falsum Introduction, lines 4 and 5. Ta-da, and we're done. Now you'll notice that I can do the exact same thing with line, with line 8 here. So negation elimination on line 8 gives me that. Conditional elimination lines 8 and 2 will give me A. Wonderful. Falsum Introduction lines 8 and 9, and we're done. And back to some of these basic rules. Let's see, problem number 2. If L, then not H. So what you want to do here, quite directly, is set up a conditional introduction. You will start off with L. You have to conclude to not H. Right? If I have L, then I can pull out D and M from line 1. Then I can do inside of that same magic box, I can do let's see, could I do a disjunction there? Oh no, that's fun. I'm going to do a negation introduction on H, so that will give me a sub box. I will assume H. I'm trying to get down to a falsum. Well, if H is true, then I can get not D from line 3. Not D. Well, the problem is, or rather, my solution is, the fact that here I have a conjunction D and M. So I have D and not D. There's my falsum. And then I'm done. Down here I have T and C. It's going to be a conjunction introduction backwards, so I have a T that I have to get to, and I have a C that I have to get to. Let's see. What can I do here? Oh, no. And I think actually what I want to do is I want to do a negation elimination. So it'll create a separate box. It'll say not T and C. And then inside of that, I'm going to run, and obviously it leads to a falsum. And then inside of that, I'm going to do a disjunction elimination on line 1, aiming for the falsum. So it will give me a line that says T. It'll give me a line that says M, and I have to end up in a falsum. Well, if I have, let's see, can I do that? If I have T, I can get C. If I have C, oh, right, then if I have T, I can get the C out of line 2. And so then I can do T and C, which is going to be negated by this line here. If I have M, then conjunction elimination on line 3 will give me not M, and that gives me another falsum, and then I'm done. So let's take a quick look right here. First, let's reset the entire thing. It's been a while since I looked at this stuff. So this is the conditional, so we're going to do conditional introduction backwards. And you start off with L and end up in not H. I can do conditional eliminations line 4 and 1. That will give me D and M. I'm going to do a negation introduction on H going backwards, so I will assume H. If I assume H, then I can do conditional elimination on line 3. That will get me not D. Conjunction elimination on the left, line 5, inside the box here. That gives me D. Falsum introduction, line 7 and 8. And there's a problem. Take a look at problem 2. I think I actually just did this one. I think I need to look at problem 3. Yep. So we'll get rid of all of that. We can do negation elimination on our conclusion. Notice that we're always driving down to a falsum. Then inside of here we're going to do a disjunction elimination, driving to a falsum, obviously inside the box. So there we go, we got our two boxes. Conditional elimination, lines 5 and 2 will give me C. Then I can do conjunction introduction, that gives me P and C, and there's my falsum. That's the first one. And then we have conditional elimination, lines 9 and 3. That gives me the not and falsum introduction, lines 9 and 10, and there's the whole problem. Now notice again that step 1 was really to sit there and intellectually work our way through the problem before actually dealing with it directly. And you want to do this because otherwise you're just going to start hitting buttons, kind of hoping for something to come up. My approach is always take a look at that conclusion, take a look at how it breaks down, right? Is it an atomic statement, or does it have, is it like an equation? If it's an equation, how does it break down? That tells you the last step that must have been done, or at least gives you options there, and then you can start taking a look at what you have on the board that might get you there. I suggest not just hitting negation introduction or negation elimination because you can. Think about where that's going to lead you. I have seen some of these problems turn into, like 40, 50 lines, and it's like, like a 4-step problem. And that's because ultimately what we're doing is we're hitting buttons instead of actually thinking our way through the problem. So make sure that you think your way through the problem to the best of your ability first, sort of work out roughly what you think you're getting, and then approach it. Another possible way of doing this is sort of ask yourself, when looking at the premises, what can you actually pull out of it, right? How close can you get to breaking it down to atomic statements with what you have? And then that will give you a sense of what exactly you're working with as your tool set for that specific problem, and that should make your lives a little bit easier. Alright, if you have questions, comments, concerns, any of the rest of that, leave a comment in the comments, or feel free to email me, and I'll get back to you. Alright, take care.